Okay, hi there. Today I'm going to be looking at chapter 1-3 of pre-calculus. It's on distance and midpoint. There's two formulas here, one for midpoint, one for distance, and these are for the points x1, y1, and x2, y2. So I usually just pick one point, make it x1, y1, and the next one's x2, y2, and then you plug the numbers in. You should have seen these before. Certainly in geometry is probably the main place, but we do use them in Algebra 2 also. So anyway, I'm going to jump right in here with what's the distance and midpoint for these 2 points. So I think I'll do the distance first. So distance. So I'm going to have this be x1, y1, and this one can be x2, y2. And when I plug them in, I get -3 minus -2 squared plus -4 minus 1 squared. Remember, these are in parentheses, so if you get a negative number in there, it becomes positive. So this is same as -3 plus 2. So that's -1 squared plus -5 squared. So I'm getting positive numbers here. So d equals the square root of 1 plus 25 once I square them. So d equals square root of 26. Okay, I'm going to leave it like that. It's not reducible, otherwise I'd reduce my radicals. Okay, the midpoint is where you add the x coordinates together. -2 plus -3 divide by 2. Add the y coordinates together, which is 1 plus -4 over 2. Okay, and oops, that shouldn't be there. And then these will end up being coordinates. So that's -5/2, and that's -3/2. And that would be the midpoint. Okay, I'm just going to leave it like that. If you like decimals, use decimals, that's fine. Okay, next one, same directions. Find the distance and the midpoint. So D will be 1 minus 10 squared plus 9 minus -4 squared. I think I did the y's first, but it's actually the same thing if you switch them anyway, because yeah, it has the x's. So if you prefer, you can move it, but you're going to end up doing the same things. That was not what I meant to do. Okay, so now I messed that up. So that's 13 squared plus -9 squared, which is 169 plus 81, which will end up being square root of 250. So this one should be reduced, especially because that's an easy one to reduce. You know, what goes into 250? Well, 25 and 10 are the easy ones, which means you get 5 root 10, and that would be the distance. Okay. Midpoint, if I go back over here, and I add the midpoints together, add the x coordinates together, -4 plus 9, divide by 2. I add the y coordinates together, 10 plus 1, divide by 2. And that will give me my answer, what's that, 5/2 and 11/2. And that's it. Yep, I'm good. Moving on. All right. Fun with fractions. So here we go. First, we're going to do the distance. x2 minus x1 squared plus y2 minus y1 squared. Okay, I know this looks bad, but it's actually not so bad because 4 and 2 are easy to get common denominators for, as is 3 and 6. So this is really the same as negative 3/4 minus 1/2 is 2/4, right? That's the same. 1/3 is the same as 2/6. Okay, so this is getting easier. Next, I'm just going to combine them, right? Negative 3/4 minus 2/4 is negative 5/4. Negative 2/6 minus 1/6 is 1/6. Now I'm going to square the fractions. Remember, to square fractions, you can square the numerators, square the denominators. These both can be positive when you're done. So this is 25 over 16 plus 1 over 36. Okay, and now I need common denominators. 16 times 36 is going to be 144, which will give me 25 times 36 is... So 144 is a common denominator. I'm going to multiply 16 by 9 to get to 144. I'm going to multiply 36 times 4 to get to 144. So 25 times 9 is 225. And 4 times 1 is 4. So I get this, which is 229 over 144. And remember, I still have this radical here. So I'm going to take the square root of the denominator, which is 12, and now I got a rational denominator, which is good. All right, so I don't have to get rid of the radical in the basement. All right, so that's the distance. I know that was kind of a little messy. That's probably about as hard as they get. Midpoint. Midpoint should be much easier. The midpoint, I add my x's together, which is negative 3/4. Oops, negative 3/4. Plus 1/2 over 2, and the y coordinates, you get 1/6 plus 1/3. All right, so same idea. I can do common denominators. That's 2/4 over 2. This is 1/6, which is 1/6 plus 2/6 over 2. And now when I add those together, I get negative 1/4 divided by 2 and 3/6 divided by 2. So 1/4 divided by 2 is negative 1/8, and 3/6 divided by 2 is 3/12, which I can reduce into 1/4 and negative 1/8. Okay. Remember, if you're dividing by 2, that's take a fraction divided by 2. You flip and multiply, so that really is negative 1/4 divided by 2 will be negative 1/4 times 1/2. Okay, flip and multiply. Just so you guys get the idea of what I did there. Okay, all right, that was that one. So, next one. And then sometimes you might get a no-brainer one like this. Like, what's this distance? If I look at this from a quick, I notice that the y coordinates are the same, which means, you know, here's 9, 1, and here's negative 1, 1. So it's a straight shot right across, which means your distance is just the distance between those 2 points, because it's straight horizontal line, which makes it 10. Okay, no need to use the formula. You will get the same thing if you use the formula, but this is an easier way. And the midpoint will be halfway in the middle there, which would be 5, right? So that's over here at 4, which means my midpoint will be 4, 1. Okay. 5 and 5, distance is 5 between the two. Okay. Another no-brainer. Once again, I can see that the coordinates match on the x's. So if I was looking at this from a graphing point of view, here's -2, 7. Let's say that's 7. And here's -2, -3. Which means, what's the distance here between them? Well, that's 7 units, and that's 3 units, which makes it 10 units. Once again, distance is 10. What's the midpoint? The midpoint will be halfway in the middle of those. So if it's 10, you go down 5 units, which will land you at 2. So my coordinate for the midpoint would be -2, 2. And that's the answer. Okay, so those are no-brainer, easy ones for you. When you see those matching up, you're going to be psyched about it. Okay. Next, coordinate triangle. A, B, and C, 3 points. And they want to know, is it isosceles? So the way you do this is you do the distance point, like, kind of 3 times. I want to know what the 3 lengths are, and then I can look at them and see if any of them are the same. Remember, isosceles triangle has 2 sides that are equal length. All right, so if I go between A and B, so look at that, which means, this is one of those easy ones, because this goes at like 0, 2 is here, and then 4, 2 is over here, which means my distance is 4. So I'm going to take the easy way out and not use the distance formula there. Okay, BC, if I go 4 minus 2 plus 2 minus 5, the square root. So that's 2 squared, and that's 3 squared, which is 4 plus 9 is √13. And then if I'm looking at the other side, which would be AC, I'm going to go from 2 minus 0 squared plus 5 minus 2 squared. Once again, 2 squared plus 3 squared, that's √13. So these two are the same, so yes, isosceles. Okay, and you got to have the work to prove it too, just saying it, yeah, it's isosceles. You could say because BC is congruent to AC. Okay, that's your best answer. All right, next one. Same idea. This time, they want to know, is it a right triangle? So, so I need to know the lengths of the sides, and I'm going to plug it into the Pythagorean theorem and see if it's true or not, okay? Remember, Pythagorean theorem only works for right triangles, and if you get a squared plus b squared equals c squared, then it's a right triangle. Okay, so if I go AB, ooh, look, the x coordinates match again, which means this is 1, 5, and this is 1, -2, which means my distance is 7. That was nice and easy. BC. Ooh, looky, looky, looky. This is getting nice. They gave me some gifts in this one. Because in BC, both the y coordinates now are the same, which means 1, -2 is here. And 5, -2 would be here. So what's the distance between them? Between 1 and 5, that's 4. And last but not least, AC. So this would be 1 plus 5 5 minus 1 squared plus negative 2 minus 5 squared equals 4 squared plus negative 7 squared. So that's 16 plus 49, which is root 65. Okay, so here we go. Let's see which one's the biggest side, because this is, I'm going to plug it into the Pythagorean theorem. So what is important is which one's the biggest. Put a little question mark there. Does it equal? So square root of 65 is bigger than 7. Okay, so that's actually the biggest one. And if I square 4, I get 16 plus 49 equals square root of 65. Oops, sorry, not square root of 65 because I squared it. So this was square root of 65 squared, which is regular 65. Square root knocks that out. Okay, so that is 65 equals 65. Therefore, yes, it's right triangle. All right. Good. Next one. So there's an equation for the area of an equilateral triangle, and it's this. Square root of 3 side squared over 4. It's not that complicated. You know, if this is a 30, 60, 90 right triangle, then this is going to be 3, and this will be 3, and this will be 3 root 3. So if you take the 1/2 the base times the height, that's where the 1/2 comes from. And anyway, you can quickly come up with that way, okay? You don't have to remember all that, but that's what the formula is, which means if I was asked you for the area, S is, in this case, going to be 6. So if I take the square root of 3 and I plug in 6 squared over 4, what would my answer be? The area would be 6 squared is 36. Square root of 3 over 4, which can be reduced. Those are both even, so I can divide them both by 2, which gives me 18 halves. Oop, they're divisible by 4, which gives me 9. 36 divided by 4 is 9 root 3. Units squared. Okay, that would be the answer. Nice, easy way to find the area of an equilateral triangle there. Good one to write down in the notes. All right. Next, we're going to do x and y intercepts. This is the last thing I'm going to be tackling today. I got a handful of these. And in case you've forgotten, to find the y-intercept, you plug in 0 for x. And to find the x-intercept, you plug in 0 for y, okay? So I'm asking for the x and y intercepts, and I'm going to keep this relatively simple by writing it down like this, where, you know, here's where I plug in 0 for x, and here's where I plug in 0 for y, and I'm going to list my tables right, my answers right on the table here, okay? So if I take, let's do the easy one first. I plug in 0 for x, then I get 25 minus 0 squared equals y. So therefore, y equals 25. That was nice and easy. See, that one's the easy one. And then if I take the other one, where I plug in 0 for y, I get 25 minus x squared. And then if I add x squared to both sides, I get x squared equals 25. So I'm actually going to end up with a couple answers here, because if I take the square root of both sides, I get plus or minus 5, okay? So I'm going to put them both here. And there's my answers, okay? Because sometimes, you know, especially with that one, you know, you're going to get just, it's a curve where it goes across the x-axis more than once. All right, next one. So once again, I'm going to set it up the same way. Here's my x, here's my y. If I plug in 0 for x and 0 for y, what do I get? Let's do the easy one first. If I go 0 for x, I got y equals 0 plus 2 squared. So y is 4. That one's easy. Now the harder one. If I plug in 0 for y, then x plus 2 squared. Solve that. So if I take the square root of both sides, I get 0 equals x plus 2, and then you solve that, you get subtract 2, you get x equals negative 2, and there's the other one. This one, ooh, a linear one. You've got to love the linear ones. So if I take 0 there, 0 here. All right, so if I plug in 0 for x, I get y equals negative 3. If I plug in 0 for y, what do you get? Well, you add 3. So I got 7x equals 3, and therefore when I divide by 7, you get 3/7. And there's your answers, okay? This one. If I plug in 0 for x, I get the square root of 3. Not pretty, but that's what it is. And if I take 0 and plug it in for y, what do you get? Well, this one, square both sides to get rid of the radical. 2x plus 3. Okay, subtract 3. You get 2x equals 3, and then divide by 2. You get x equals 3 over 2. And there's the answer. Of course, it should be negative 3 over 2. Don't be sloppy. Okay, there we go. This one, same idea. Remember, you're just plugging in zeros. 0 and 0. All right, so I'm going to do the easy one first because that's the kind of guy I am. 7 times 0 minus 5. 7 times 0 is 0, negative 5. Absolute value of negative 5 is negative 5. Sorry, is positive 5. And then you make it negative. So that's going to be negative 5. And then if I plug it in here, so I can divide by negative 1 here. Get rid of that. Those cancel. Then I got the absolute value of 7x minus 5 equals 0. So usually you have a plus and a minus here because there's an absolute value, but in this case it's 0, so there's no reason to go plus 0 and minus 0. Just go 0 equals 7x minus 5, and that'll take care of both of them. So if I add 5, I get 7x equals 5, and then I divide by 7, and I get my answer. X equals 5/7. And that'll be what I plug in here. All right, this one, woohoo, to the 4th power. X, Y, 0, 0. All right, do the easy one first. Plug in 0 for x, and y equals negative 81. I like that one. Next, plug in 0 here, and I get x to the 4th minus 81. If I add 81 to both sides, I get x to the 4th equals 81. I'll take the 4th root of both sides. Remembering I got to take plus or minus there. So I get plus or minus 3 equals x. Yep. Sorry, I was just double checking my notes. All right, 2 answers, plus or minus 3. There we go. Next one's U try. Thought I was at the U try. We're almost there. All right. This one. X, Y, 0, 0. So I plug in 0 for X. And Y squared equals 8. So therefore Y equals the square root of 8, which can be reduced. 4 times 2. That's a scrubby 4. So that's 2 root 2. Now if I plug it in the other place, I get 0 equals 8 minus x. This one's actually the easier one. 0 equals 8 minus x. Yeah, it is. Look how easy that's going to be. Add x, there's the answer. X equals 8. All right, you try. See if you can come up with the two answers here. X, Y, 0, 0. Plug in 0 for x, 0 for y. And that is my last problem for the day. I'm going to close it out with a little more music. You guys have a great night.